Cryptosporidium and the Analysis of the 1993 Milwaukee Outbreak by Danielle Worthen. So, what is Cryptosporidium? Let's talk a little bit about its biology. Cryptosporidium, or sometimes called crypto, is a protozoan in the family Apicomplexa. It happens to be very similar to Plasmodium, which causes malaria, and Toxoplasma, which is the leading cause of foodborne death in the United States. There are currently 16 known species, which have affected all 5 groups of vertebrates. The species Parvum and Hominis are the ones that infect humans the most, but Canis, Felis, Meleagridic, and Murus also have been known to infect humans. The commonality between all the 16 species is that they have 4 naked sporozoites within a thick-walled oocyst. Now, something interesting about Cryptosporidium is that unlike any other protozoan, it can complete its entire life cycle within one host. And here's a little figure that goes over it roughly. So basically, this poor little child here eats something contaminated with Cryptosporidium, and it enters into the intestines and into the small intestines where the little sporozoites break out of its little hard shell. Then they hunker down in epithelial cells and reproduce both sexually and asexually. After that, what's remaining are 2 new oocysts, which are then excreted from that host and waits until another host picks it up. Something interesting is that Cryptosporidium can actually last for months in both freshwater and saltwater, which makes it really resilient. Now we just went over Cryptosporidium life cycle in the last slide. This slide lists the main points that we just talked about. And there's also another fun diagram. This one is from the CDC, and it talks about the life cycle again. And the bottom one has just a little more details that goes into it. It's a bit complicated. It's more of a complicated life cycle than other protozoans, but it's quite effective since it can all happen in one host. Effects on humans. What does this all have to do with us? Cryptosporidium causes cryptosporidiosis, which is basically a watery diarrhea. It is self-limiting, but it can be quite serious in children and those with compromised immune systems, such as people with AIDS. They are already sick and their immune systems are already weak. So if someone with AIDS contracts cryptosporidiosis, that can be very serious and can even be deadly. It can affect anyone, and it is found all over the world, in undeveloped countries, in developed countries, the old, the sick, anyone. It happens to be the leading cause of waterborne disease. It has been reported in people from ages 3 to 95. So really it can affect anyone. Something interesting is the children in China, it's been reported that about 50% will contract this illness. And almost all the children in the slums of Brazil, so children in places that do not have readily clean water, or if they get sick, they don't have very much education or water that they can grab quickly to help them recover very well. These are the cases that can be much more serious than, say, cases to healthy people in the United States. Many cases also go undiagnosed. It is, for most people, just a diarrhea, and not everyone reports it and goes to the doctor. So there are a lot of cases that go undiagnosed. In the United States right now, about 3 people in every 100,000 will contract it each year. Cryptosporidium is the reason for about 60% of waterborne outbreaks worldwide. That's a lot. The next one actually is Giardia, which is the reason for about 35% of outbreaks. And so those two, Cryptosporidium and Giardia, are really the two dominating waterborne illnesses in the world. Now, how do you get cryptosporidiosis? How does the Cryptosporidium protozoa actually get into a human's body? Humans are infected when ingesting contaminated water. This can happen from drinking water out of taps or from the pump at your campsite, and from water from lakes and pools that have been contaminated, just a little water splashed into your mouth and you accidentally swallow it. Since you really don't need much of the protozoa to become infected, just a little from a pool or a lake will actually make you sick. Now, water is contaminated when infected feces reaches the water source. This can happen from sewage overflow, from an unmaintained septic system, or one that's starting to rust out and just no one's really paying attention to it. It can also happen from agriculture runoff, because remember, and all 5 types of vertebrates have been infected, so cows and pigs can actually be infected, and their feces can run off into the water sources that we end up drinking. Cryptosporidium is found almost everywhere. It's tested in a lot of water sources. Most of it's at an amount that it really doesn't affect us, but it is really all over, which is kind of icky since they're just gross little worms. Through testing, it's been found that about 12% of all United States groundwater supplies have been tested positive for Cryptosporidium. Okay, let's talk about symptoms for cryptosporidiosis. Diarrhea is the big one. Most people probably think about diarrhea when they think about cryptosporidiosis. But you can also have stomach cramps, nausea, vomiting, fever, and weight loss starts coming in when you lose so much fluids and you really don't feel like eating very much, and also dehydration. And when you get dehydrated and don't drink enough to replenish what you're losing, that's when it really becomes serious. Now, the symptoms generally show within 2 and 10 days, and they can last between 1 and 2 weeks, and it's even been known to last up to 4 weeks. Some people are even carriers and have no symptoms. Now, those with the compromised immune system, like AIDS, or I know cancer, people on chemotherapy that are already struggling, these are the severe cases that can even result in death. There is really no treatment because most of the time it is self-limiting, and the FDA never approved any drugs or any treatment for this, which is fine besides those that are really affected by it. So let's say Cryptosporidium has been tested positive in our water. Now, how do we remove it? But something interesting is that its hard shell makes it really resilient, like way more resilient than probably most people think. It's thought to be 240,000 times more resilient than Giardia, which is, remember, the second leading cause of waterborne illness in the world. Now, for smaller scale water in residence, like in a home, you can boil the water for at least 1 minute, and the Cryptosporidium is either killed or becomes inactive from the boiling water. There's also filters that can be used at home that can filter out not all, but the majority of Cryptosporidium, enough that it really won't make you sick anymore. And those filters that are good for Cryptosporidium has to have one of the 3 of these listed on its box to make it good. It has to be able to remove 0.1 to 1 micrometers in particle size, or it has to have reverse osmosis and or meets NSF standard number 53 for cyst removal. For large-scale water, like public water, generally there's an ultrafine filtration like this diagram shows that is used to remove cryptosporidium, which basically is just that it removes particles from 0.1 to 1 micrometers in size. It's similar to that same one that people use at home, but for large-scale waters. Now, you already have cryptosporidium. How can you help prevent the spread of it to others? It's very simple. Basically, proper hygiene. It's simple, but it is very effective. Wash your hands after using the bathroom. Don't share towels. Keep your bathrooms clean. It's recommended that you shouldn't go swimming in water for at least 2 weeks after your symptoms have subsided. Don't prepare food for others. That's just gross. You can still be carrying little sporozoites on you. And it is recommended to stay home from school and work and church or whatever, wherever you normally go, for at least 48 hours after your symptoms have stopped. Now, the history. The history of cryptosporidium is actually quite short. This is probably because before this, we lacked the technology to actually detect it because they are so small. In 1907, E.E. Tyser discovered it in the intestine of a mouse. And it really wasn't thought about for another 69 years. No one really paid much attention. It was just listed in a book somewhere. Until about 1976, when this poor 3-year-old girl contracted the illness. And she had diarrhea, and people were scared because they didn't really know much about it. And that's when it really started having light shined upon it. In the 1980s, when AIDS was prevalent in the US, cryptosporidium was worried about because people that were already sick with AIDS started becoming sick with cryptosporidium and causing some deaths. Now, in 1987, in Carlton, Georgia, this was the first waterborne outbreak from cryptosporidium from public works, from a municipal public water system. 13,000 people became sick. Since then, it's not like super frequent, but it is enough to be a threat. Outbreaks have occurred worldwide in developed countries, undeveloped, in the United States, everywhere. And some examples are listed down there from Canada, Wales, Australia, Sweden, Ireland. There's more than that. Those are just a few. And in the United States in 1983, in a New York City daycare, some children started spreading the illness around, which was scary to those parents and those involved. In a Los Angeles swimming pool in 1988, some started contracting the illness. In a Pennsylvania campground, where people got some water from their pump, that was contaminated, and I think about 500 people got sick from that incident. In Milwaukee in 1993, this was the biggest outbreak that's of cryptosporidium that has ever been known. And I'm actually from Milwaukee, well, a few miles north of Milwaukee, and this is the reason why I chose cryptosporidium, because growing up, I heard about it and I knew about the outbreak, and it impacted me, and not like majorly, but when we went swimming in the lakes, there was always warning signs before you go swimming. So this is why I decided to do the project on this topic. Now, the Milwaukee outbreak happened in the spring of 1993. So I was just a child at the time, but I remember, I don't remember specifically this outbreak, but I remember the repercussions of the outbreak. And it happened, the Milwaukee public water system was contaminated. On April 5th, a bunch of people called into work and school, and like so much that people were worried and started wondering why. they called in sick and they said they had a diarrhea and they couldn't go into school. On April 7th, there were so many people calling in that people were becoming more worried, and 2 separate labs in the area identified cryptosporidium in 7 adult stool samples. And after this, basically 403,000 people became infected. That was within a 5-county area in Milwaukee, Wisconsin. Most of them, and they all got the water from the Milwaukee public water system, and also a few people that happened to visit during the contaminated time. Now, the total area population is only 1.6 million, which makes it about a quarter of the people were infected and had diarrhea and were sick and stayed at home. There's roughly about 100 deaths from this infection, and 85% of those deaths had been reported that they had had AIDS. Now, I found this interesting. The CDC had conducted a telephone survey shortly after the outbreak, and they found these results. About 88% of the people infected didn't receive any medical attention. They stayed home and waited it out, and they were fine. 11% got scared, went to an urgent care. They were told they were sick and went home. They were fine. Now, about 1% of those infected were hospitalized. Now, the CDC had ranked all 403,000 people into 3 categories of mild, moderate, and severe, and calculated how much this outbreak actually cost the area. So they decided that $3.17 million was used for medical costs. Most of that was from severe cases, those that were hospitalized. $64.6 million were lost in productivity costs. So the whole outbreak totaled about $96.2 million. Now, this little clipping on the right is from a Milwaukee newspaper from the time of the outbreak. Look, it's about a few weeks after the outbreak. There had been a water ban for the week before, they said, and it was just lifted, but it says that people probably still shouldn't drink the water. But interestingly enough, it goes on and really downplays the whole outbreak, even though so many were sick. I think they were just trying to save themselves. They kept talking about how cryptosporidium is found everywhere and, whatever, you're fine. But I just found that interesting. They really downplayed it. Once people became getting sick, an investigation started going forward. They wanted to know why. So in Milwaukee, there are 2 water treatment plants, a southern and a northern plant. An investigation showed in the southern plant that during March 21st and April 7th, there was an increased turbidity. Not just a little, but overwhelmingly increased turbidity. For the past 4 decades, turbidity never went above 0.4 NTUs, which an NTU is just a turbidity unit, something to measure it by. But during that time of March 21st through April 7th, it had reached multiple times, all the way up to 1.7 NTUs, and it stayed quite high that whole time. But during that time, nothing was ever tested over legal limits, and no alarm was set off, including for coliforms. But the investigation actually showed that their water monitors were faulty. They were installed incorrectly, and they weren't even working. Now, an ice company that had used water during that time of bad water, their ice was melted and it was tested and it was confirmed for cryptosporidium. Now, why? What's the real source of this outbreak? This is awesome. So look at those awesome pictures. That is raw sewage and stormwater going directly into the lake. This happens a lot in Milwaukee. This is what I grew up with. It's really sad. You'd think in a developed country that we wouldn't just dump our sewage into our fresh water sources that we use to drink. But it happens a lot, and it really needs to stop. So it was found out that the outlets for this raw sewage was very close to the drinking water inlets where the Southern plant took in the water from Lake Michigan. Why does Milwaukee dump all their sewage into the lake? Well, it rains quite frequently there, and oftentimes their system can be overwhelmed. Their two plants can't keep up with the sewage that they have to clean and treat, so they dump it. At the time of the outbreak, about 50 to 80 overflows happened each year. Now, about a year after the outbreak, Milwaukee finished their deep tunnel project, which was supposed to alleviate some of this dumping. So what is that project? Chicago has a very similar project, and Chicago is only about an hour and a half south of Milwaukee. So this project cost about $3 billion, and like I said, it's supposed to alleviate dumping into the lake. It consists of 17 miles of underground pipe, and it's supposed to hold 405 million gallons of water. When there's too much water, too much unclean sewage water that the two plants can't handle, the water goes down into these deep tunnels and waits until the plant can catch up. So it just sits there. Now, after this project is done, only about 2 to 3 overflows go into the lake. But it's still 1 billion gallons of gross water, uncleaned cryptosporidium containing water into the lake. I don't think it's very good. Before the project, even though there were like 50 to 80 overflow events, they estimated it was about 8 billion gallons of sewage into the lake, and now there's still 1 billion gallons. So it's less frequent, but the 2 or 3 times it happens, I think it's just much more water. Now it's done, but I don't know what happened. They must have not done the project very well, because already the pipes are not very well maintained, and they're leaking and contaminating not just lake water, but groundwater and other water sources, and it's becoming a problem again. In 2001, 15 years ago already, the Red Star Yeast Company in the area sued the Milwaukee public system, the water system, because their well water that they use for their yeast company, which is technically a food that they sell to others, it was contaminated, and it was tested positive for cryptosporidium and other bad water things, just bad in general. Now this is the question. Milwaukee, it isn't even that big of a city, but they have many water problems. Is this system set up for possible future outbreaks? Now, conclusion. What did we overall learn about cryptosporidium? It is everywhere. Developed and undeveloped countries. It is found in minute amounts in many water sources, even in the US, but most of the time it's not enough to actually hurt or make anyone sick. Outbreaks are continuing all over the world, not at crazy frequencies, but it is happening. Now the small size in the cryptosporidium's hard shell make it quite difficult to treat and kill, and it's quite resilient. And it is thought that very small amounts of ingestion can make someone ill. Now in 2001, the federal guidelines for cryptosporidium was updated, and it is now, the MCLG is now at 0. They don't want any cryptosporidium found in water. And I think partly because of this update, it's really helped. It's like in the 1993 outbreak that made so many people sick. It wasn't above any level, but it obviously hurt a lot of people. So they tried to update their guidelines, and that helped. But I think as we make better technologies to help filter out the cryptosporidium, because remember, the filters that we use, they remove most, but not all of them. They can still sneak through. So as we get better technologies, and as more people use better water practices, unlike Milwaukee, that hopefully the outbreaks will begin to decrease even more. And that is my Cryptosporidium project. Thank you.